So, patterns and sequences. So, for example, start off with the basics of patterns. What do we reckon is the next three tiles? That's green. So, what do we reckon the next three is? You're probably right. It's green, red, isn't it? So that's the next three. Green, red, and then blue. So, if we were to try guess, what would be the pattern for yellow? You know what the pattern is. It occurs every four. So it's the first one, and then it's the sixth one, and then it's the 11th. So it's 1 plus 0, 1 plus 5, 1 plus 5 times 2. So this is very, very important. Alright? So when we see a lot of this, where I know it's 1, 6, and 11, we have to try to see what is the pattern for yellow. The pattern is it occurs every 5, but it doesn't occur 5 and 10 and 15, does it? No, it's 1 and then 6 and then 11. So it occurs every 5, but the first one starts at. So the first one is 1 plus 0. Then you go and jump on 5 more. 1 plus 5 times 1 is 6. 11 is 1 plus 5 times 2, which is 10 plus 1 is 11. So what would be the next one down here? How would I find what would I write for the 7 people? Exactly, 1 plus 5 times 3. And what that creates, which we'll be looking at today, is a pattern that looks like this. 1 plus 5n. Alright, so that's the pattern. 1 plus 5n. Alright, and what that means is if you were to start the pattern at 0, 1 plus 5 times 0 is 1. Alright, so 1 plus 5 times 0 is 1. If you were to pick the next one, it's T1. 1 plus 5n again, which is 1 plus 5 times 1, which gives us 6. And the next one is T2. 1 plus 5n is our pattern. 1 plus 5 times 2, which is 11. T3. 1 plus 5n is our pattern, which is 1 plus 5 times what was that? Which is 16. So it's all about finding a pattern which helps us find every single one. Is that right? So, if I ask you then, when does green occur? What are the numbers that green occurs? By the way, that's blue. Alright? They're blues. That's green. Sorry. Yeah, no. It's on the laptop. On the laptop you can. It's very poorly put. So, this is green, and that's green. So what numbers are there? So this is number 2. This is number 7, and this is number 12, isn't it? So we have 2, 7, and 12. What do you reckon is the pattern so for green? No, 1 plus 5 will give me the pattern for yellow. What we reckon is going to be the pattern? 8, isn't it? It's going to be 2 plus 5. So if you think about it, the first one is just 2, because it's the second one. The next one is 7, so it's 2 plus 5 times 1. The next one will be 2 plus 5 times 2. What one down here? Which is 5 times 3 is 15 plus 2, which is 17. So if we were to write that in a pattern range, our pattern would be 1 plus 5, and this one would be Alright, so we learn how to create them. Right. The next thing we're going to look at. A linear sequence. Alright, so a linear sequence. Now, a linear sequence is a set of numbers which go up by the same amount each. Is that alright? So, for example, our first term is 3, our next one is 5, our next one is 7, our next one is 9. What will be the next? And then? At 13, we go to 17, we go to 15, and then 17. What's going up by each time? It's going up by 2. Exactly. Alright? And what we must know, this is known as T1. Alright? So the first term, which is often shortened to T1. This is T2, and this is T3, T4, T5, and so on. Alright? So you're going to be hearing me mention that an awful lot. Now, the general rule for a pattern is what I was doing over here. Alright? What I was looking at there in the first bit. So what I mean by that is when I asked you about green first of all, so no, first one yellow. And I said that the pattern for yellow was 1 plus 5n, didn't I? And then the pattern for green was 2 plus 5n. The name put on that is the general term. Alright, so this is all a little bit of background before we start jumping into the two questions. Alright? So, the general term, that's what it's called. 2 plus 5n and 1 plus 5n. It's a rule which allows you to find the pattern of any number. The number pattern of any one in the sequence. Alright? So, for example, if you have Tn is equal to 2n plus 3, this is a general term, right? This is the general term. Tn is equal to 2n plus 3. Now, the handy thing about this rule is it allows you to find any number in the sequence. So, anyone know what T1, the first term of the sequence, might be? Tn is only equal to 1. So, n is 1 this time. I don't know what the first term of the sequence is. 2 times 1 plus 3 is 5. The first term in this sequence. I was going to say brackets, but then I'm just so you technically got it right. So this is our rule, which allows us to find any number in sequence, right? And I want us to find the first term, so number 1. So instead of n, I put in 1 because n is there. So T1 is 2 times 1 plus 3, which is 5. I don't know what the second term is. T2, which is the number? Yeah, term 2, what's the number being going to be? I don't know what the second term is. 2 times 2 is 4 plus 3 is 7. Alright, and I know what the next one is going to be. 9. 2 times 3 plus 3, which is 2 times 3 is 6 plus 3 is 9. The next one? 11. And then? So, you go all the way down. You go all the way down and look for the 100th term. I need to find a 100th term straight away, it's 203. That's what the rule allows you to do. The rule allows you to find any term in the sequence. Alright, so for example, if that's my rule, I'm looking for the 205th term in that sequence. Now, if I didn't know the rule, and I just knew it began with 5 and next one 7, I'd have to keep counting up in 2s 205 times. Take forever. So that's what our rule allows us to do. So, how am I going to find the 205th number in this sequence using the rule? I don't know what 2 times 200. Use your calculator. 413. 413, exactly. 413 413. So that's what it allows us to do. It allows us to find any term in the sequence. Is that alright? So what I'm going to get you to do now for you, I'm going to get you to do 2 questions based on that. I want you to write out the first 4 terms of the following sequence. So what I mean by that is Tn is equal to 5n plus 2. Tn is equal to 4n minus 3. And Tn is equal to 2n plus 1. I want you to find T1, T2, T3, T3, T4 for all of those 3. Off you go. Right, let's have a little look at it. So, for the first one, T1 is equal to 5 times 1 plus 2, which is 7, isn't it? Oops. T2 is equal to 5 times 2 plus 2, which is 12 even. T3, 5 times 3 plus 2, which is 17. T4, which is 5 times 4 plus 2, which is 22. So we can see each time it's gone up by 5, can we? It's gone up by 5. That's why it's 5n. It's gone up by 5. We come over here. T1 is equal to 4 times 1 minus 3, which is 1. Exactly. T2 is equal to 4 times 2 minus 3, which is 5. T3 is equal to 4 times 3 minus 3, which is 9. And T4 is equal to 4 times 4 minus 3, which is 4 times 4, 16, 13. Exactly. And what's going up by each time? That's why it's 4n. Alright, so the number here is going to tell you how much is going to go up by each time. Alright, and that's going to make sense now in a minute. And so, what's T1 down here? Plus 1, which is? T2 is? T3 is? And T4, what's going up by each time? If we look up here, then it's 2n. Alright? That's going to tell you what it's going to go up by each time. So, for example, if I had this, Tn is equal to 4n minus 3. Oops, don't use the same one that's on the board, Paddy. Tn is equal to 6n plus 2. What are the numbers down here underneath that's going to go up by each time? 6. Alright, because if you look, what? It's going to go up by 6 because it's 6n. So what I mean, like, for example, T1 here is 8. The next one is going to be 6 and 8, 14. Alright, can we see that? That the numbers are going to go up each time by what's in front of the n. Alright, that's going to tell us what goes up. Alright, so a little bit of hints right there. Right. Next little thing on this is plotting the points. So, a sequence in which each term after the first term is found by adding a constant. So it's a linear sequence. So Tn, this is our general rule, alright? Remember our general rule we were doing in the last session? Tn equal to 4n plus 1. So T1 is equal to 4 times 1 plus 1, which is 5. T2 is equal to 4 times 2 plus 1, which is 9. T3 is 4 times 3 plus 1 is 13. And T4 is 4 times 4 plus 1, which is 17. If you were to plot these points on a graph, we can see what? They're going up in a straight line. So what I mean by plot these on a graph, you put 1 into your function, you go out 5. So you come out 1, you go for 5, and that's the first one. You put 2 in, and you go out 9. You come out to 2, so you can't see this number. You go out to 2 and you get 9. The next one, go out to 3 and you get 13. Out to 4 you get 7. Alright? So that's how you plot a linear path. Alright? So what I want you to do is, with that in mind, I want you, for Tn is equal to 3n minus 2. I want you to plot it. Find the first 4 points first of all. And then plot it. So very like what's done before. I want you to do the exact same as what's done up there, except do it for 3n minus 2. I want you to find the first 4 points and then plot on the graph. So, do you know how to plot a point with your x and y? This is your x, and this is your y. So what's the bracket is your x, and then the 5 is your y. So this is your x-axis on the bottom, and that's your y. So if your x is 1, you go out as far as 1, and then you go up to 5, that's your y. Alright? So for this one, you go out to 2, and then your y is 9, so you go up as far as that. Next one is 3, go as far as 3, up to 13. Next one is 4, you go up to 4. Right, so let's have a little look at it then. We get T1 first of all. So T1, 3n minus 2. So that's 3 times 1 minus 2, which is 1. So our first point is 1, isn't it? T2 then. 3 times 2 minus 2, which is? So our second point is 2, 4. T3 is 3 times 3 minus 2, which is? So our next point is 3, 7. And T4 is 3 times 4 minus 2, which is? So our next point is 4, 10. So we plot our first point. We go out to 1 and up to 1. Is that alright? So we go out to 1 and up to 1. Our next one is out to 2 and up to. Our next one is out to 3 and up to. And the last one is out to 4 and up to. And we can see then if you were to draw a straight line between them all, it shows how it's linear. And what's it going up by each time? 3. And how do I know it's going to be 3? Because it's 3n. Alright? So I'll give you a few of those to practice them for homework. Right.
How we did it in school was we did like X and then the Y in the box and then we put that in the middle and then we put
the X on the left and then the Y. Yeah. That's another way of doing it.
We didn't actually do it. I actually did
Good stuff. Right. So this time now, we have the sequence, but we don't have the pattern. So we don't have the rules. Remember last time we had the rule that Tn is equal to 2n plus 3, or Tn is equal to 5n minus 1. This time they give us the numbers, but they don't tell us what the rule is. So this time we're looking to find the rule. So the first thing we must do is figure out what the difference is. So anyone know what the difference is between all our 2? Exactly. The difference between each one of our ones is 2. The next thing we got to do is find T0. Alright, T0. 0. So what I mean by that is, what's T1 here? What's T2? T3, T4, and T5. So what do you think T0 is going to be? 1. Exactly, isn't it? Because it's going to be 2 back. And then our formula for figuring out what it is. So our formula is for Tn, which is our general rule, is Tn is equal to T0 plus Dn. Best way to put that is Dn plus T0. So if we take this one here on the board, what's D? What's the difference? D stands for difference. It's 2, isn't it? Because it's going up in 2s. So Tn is equal to 2n plus what's TO? What's the first? What's TO? 1. And there's our path. Alright? So it makes sense though. If you put 1 in here, 2 times 1 plus 1 is 3, isn't it? 2 times T2, 2 times 2 plus 1? 2 times 3 plus 1 is 7, 2 times 4 plus 1 is 9. It allows us to find any one. So this time, they gave us the pattern, and we have to put the numbers with it. Right. What I want you to do is, I'm going to write out the pattern, and I want you to get Tn. Is that right? So, find Tn for 6, 9, 12, 15. Find Tn. Ooh. Touch you on, please. Right, let's have a little look at it. So first things first is we got to find our difference. So what is our difference between 6 and 9? 9 and 12? 12 and 15? So, therefore, Tn is equal to Dn plus TO. Alright? dn plus TO. Right, what is our difference? 3, isn't it? What's TO? 3, exactly. Therefore, Tn is equal to 3n plus 3. And that'll help you find any number in that sequence. Right. With that in mind, I want you to have a go with these 3. Off you go. Have a go with those 3. No, negative 2. Sure. Right, let's look at it. So, T1 is equal to 1, T2 is equal to 3, T3 is equal to 5, and so on. What's the difference in each one? 2. What's T0? So Tn is equal to 2n minus 1, isn't it? What's the difference in each one here? What's T0? Minus 1, so Tn is equal to minus 1. Good stuff. What's the difference here? What's T0? Tn is equal to 4n minus 1. Is that okay? Stuff. Right, next little bit. We're flying through this. Really good stuff. So, when it comes up in an exam paper, it's going to look a little something like this. So, how many matches will be needed for the fourth and fifth shapes? And then find the formula in terms of it. What's the right side? Find the formula? Find Tn. Is that okay? So, first things first, race. How many matches are needed for the first one? 5, isn't it? 1, 2, 3, 4. Juliana, how many needed for the next one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. 9 yet? 1, 2, 3, 4, 5, 6. How many are needed for the last one, guys? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Exactly. So, we know 5, 9, 13. How many are we going to need for the fourth and fifth? We're going to need 4. You're right. We're going to need 17. Exactly. How many are we going to need for the fifth? 4. Yeah, you're on the right line thinking. 21. So this is what they show you. So what's Tn going to be then, do you reckon? 1. Exactly. Good stuff. If they're their heads in all that, so Tn is going to be 4n plus 1 because T over. Is that right? Flying through. Right.
With that in mind, I want you to have a look
At this question. Only 15 minutes left, guys. We're flying it. Right, have a go at that question. the word I've been saying the whole way through the class. What type of sequence? Begin with L.
Units in terms of N. Is that like the...
It's like TN. The last one is tricky.
Do we go up to 6 for the TN one?
No, just find TN in general. You don't have to find T1, 2, 3, 4. Just
Oh.
find TN itself. And Julia, any idea what the last one? That's alright. So if you were to go up with all the numbers, why wouldn't any of these patterns have 2 of them matches? So first one has 3, the next one has 5, the next one has. Why doesn't one of the patterns have 2 of them matches? They're all? Exactly. Stop. Right, let's look at it. So, if the pattern is continued, how many matches will be needed for the 4th, 5th, and 6th diagram? So, how many matches are going to be needed for the 4th? 9. And the 5th? Sorry? 11. And the 6th? 13. The amount of matches used in the diagrams for this form what type of sequence? Linear sequence. There's 2 sequences we must know for junior cert. Linear and the one we're going to look at now in a minute. II, triple I. Find the formula in terms of N for the nth diagram. Good stuff. How many matches will be needed for the 50th diagram? How do we get that? We say Tn is 2n plus 1, yeah? So this time we're looking for T. T50, exactly. Which is 2 times, which is 101. Good stuff. Don't worry about it. Right, IV. That was, and last answer is exactly. Why is there no diagram pattern needing 200 matches? Because they're all odd numbers. Or if you look at it, another way of explaining that, Tn is equal to 2n plus 1, yeah? And we check, is that possible to equal 200? 2n equal to 200 minus 1. 2n is equal to 199. Is 199 divisible by 2? No. That's another way of checking it. That's the maths way of checking it. Which, the way they're all odd numbers is perfectly alright as well. Is that alright? You have to see is the number divisible by the number in front of n. Right, have a go at this one. Off you go. There's no need to construct the table. Just show what T1, T2, T3, and so on is. Ten minutes left, guys. Nearly there. Alright.
How do you make it then?
I got 7, 13, 14.
Whoa. I thought there was 5 days.
Right, I got an idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19.
I thought there was 5 days.
So then determine how many coming in T4 and T5, write out the formula and see if you can figure out the last one. You always have to find T0 if you're looking for that. Well, you need that's just the first one, so you have to find T4, T5. How do you mean I know? No, that's it. You do need to find T0 for this, but you also need to find T4. T0 isn't considered one of the first 5 patterns. What's new? That's the 253rd pattern. Which pattern has 253 tiles? So if I ask you to find the 253rd pattern, you know something 253 instead of that. I want to know which pattern has 253 tiles. The first pattern. That is one way of spending half the day doing it. There's the quicker way. And we're going to look at the quicker way. Right, so how many in the first pattern? How many is in here? 7 and 19. And what's in the next two? And Tn is equal to? Yeah, Dn plus To, which is 6n plus 1. That's alright, as long as you have that written someplace. Oh yeah, you have to find T0. T0 is 1. Right, the third bit. Now, we know Tn is 6n plus 1, yeah? If I asked you to find the 10th pattern, what would you do? You'd say 6 times 61, yeah? So we know in the 10th pattern there's 61 tiles. Exactly, that's definitely one way of looking at it. We know 6n plus 1 is equal to 253. We just don't know what n is. That's what we're looking for, isn't it? So 6n is equal to 253 minus 1. 6n is equal to 252. Divide both sides by 6. N is 42. No matter how far you go in maths, you can't run away from algebra.
Oh, minus 1. I actually divided, I went 6 divided by 252. I have 3.9.
You went, yeah, 254. You added the 1 instead of taking it out. Right, let's look at the last type just before we go. Or we won't. We'll do one more of these type of questions. We'll leave the last type for the next day. After 2 weeks' time. We're not here next Friday. So the last little bit of a question we're going to do today. Have a go at this.
Do you know everything yellow on the calculator like goes with itself? So you see here, this is like yellow.
Yeah.
And then these here are yellow. Then that means you can,
We'll be using them in 2 weeks' time when we're doing functions.
I just learned that by random.
Right, guys.
No.
Have a go at the first 2.
Maybe like 16. Oh. No, wait, it was 4 times 4 is 8. And 8.
Where are you eight?
Wait, no. 4 plus 4 is 8.
Yeah.
And then 8 plus 8 is 16.
No, it's not fun.
That's
So,
not 16, it's 12.
the hint they're going to give you is it has an access to do it, but we find a pattern is the very ways, that's what I want to do. It has an access to find it.
It's the answer 40 though.
So T1 is 4, T2 is 8, T3 is 12. So it's going up in.
12. Oh, I thought someone said 16. Yeah. So I was like, you just did it first, so I just put down 16.
If you do your own work, you wouldn't run into that trouble.
What's your answer though?
Yeah, but it makes everything more. That makes it more like, yeah.
I do it wrong though.
So
Finding the
it's
T's.
What do you?
just find T10. So it has an access to find. It has an access to find a pattern, but to find a pattern,
That's wrong.
it could be right, but I'm not too sure. You have to find a pattern definitely.
Yeah, the pattern is 4.
Difference is what you got from T.
What's T0? Yeah. So,
Don't write T0, look at 2.
12, 16. Yeah.
So 6 is different to me.
Oh my gosh, I just went past 36 plus 4. And then obviously 4 is the thing. And then we look at 10. Then 4 times 10 is 40.
Right, I'll put you out of your misery because you're confusing me. We're confusing each other. Right, let's look at it. So, how many this will be in the 10th rectangle? Well, in the first one there's 4. In the second one there's 8. In the third one there's 12. So the D is 4 and T0 is 0. So it's Tn is equal to 4n. T10 is 4 times 10, which is 40. Alright. How many black discs will be in the 10th rectangle?
10.
It's going up, yeah, exactly, 10. So, describe two methods of finding the number of orange discs in the rectangle. They're orange. There should be orange. Well, if you look at it, one way of finding it is T1 is 3, T2 is 6, T3 is 9. So, Tn is equal to, the difference between each one is, and T0 is 0. So Tn is equal to 3n. T10 is 3 times 10, which is 30. There's one way. And the second way is there's 40 discs altogether. And if you take away the 10 black ones, you're left with 30 orange as well. That's the second. Good stuff.